everyone, for today's lesson we are going to learn about how to write and graph equations of circles. This lesson is a lesson that you guys learned about last year almost to a T. There might be a couple things that are going to be a little bit different than what you learned about last year, but for the most part this lesson is going to be essentially a review lesson for you, which is kind of nice, especially based on the last lesson. So before we get started, I want to make sure that we practice how to write the equation of a parabola in standard form where your vertex is located at 0, 0, and you're given either a directrix or a focus. For letter A, your directrix will be at y equals -2. For B, your focus is at 3, 0. And for letter C, the directrix is at x equals 5. So go ahead and take a moment and try to come up with equations in standard form given this information. When you have an answer, go ahead and restart the video and we'll see how well you did. All right, let's go ahead and look at letter A. So for letter A, what we want to do is we want to figure out the direction in which this parabola is going to be facing. So I'm going to draw where y equals -2 is, and at y equals -2, that's going to be a horizontal line located down here, about 2 units away from the vertex. So that means that your p-value is going to be 2 units above the vertex, and our parabola is pointing up. And since our parabola is pointing up, that means we get to use a nice equation, and that's going to be at x squared is equal to 4py. Our p-value in this case is going to be located at 0, 2. So this focus is at 0, 2, so that means our p-value is equal to 2. So I'm going to let p equal 2, and I'm going to write x squared is equal to 4 times 2 times y. And so our equation is x squared equals 8y. And that is our first answer. So now let's go ahead and look at letter B. For letter B, we are told that our focus is at 3, 0. So I'm going to draw a really quick sketch of where, I know that my p-value would equal 3, but I need to know what kind of equation I need to work with. So I'm going to draw a really quick sketch of where 3, 0 is. And that's going to be located right here. I know that my vertex is at 0, 0, and I always know that a parabola hugs a focus. And here's my directrix. It's going to be a vertical line. And since my parabola is opening up to the right, that means that I'm going to be using the equation y squared is equal to 4p times x. So since I know what p is, I'm going to write y squared is equal to 4 times 3 times x. And 4 times 3 is 12, so my equation is y squared equals 12x. Next, I'm going to go ahead and I have a directrix that's located at x equals 5, so I'm going to draw a really quick sketch of that. So at x equals 5, that is a vertical line. And I know that it is 5 units away from the vertex, and my focus is going to be 5 units further away from my vertex, and that means that my parabola is opening up to the left. Since everything is equidistant, I know that this ordered pair right here is going to be located at -5, 0. So therefore, I know that p is equal to -5. And since it's opening up to the left, that means I'm going to be working with the equation of y squared equals 4p times x. So now I'm going to let p equal -5, and I have y squared is equal to 4 times -5 times x. So my answer is going to be y squared is equal to -20x. And there's my equation. Hopefully you did very well with those 3 problems, and if you did not, please feel free to email me. We can certainly have a conversation about how to come up with these equations. So now, like I said, our lesson for today is about how to write equations of circles. So what we're going to do really quick is we're going to write down everything that we remember about circles from geometry. So some things that you guys might remember is that the center point is equidistant from every point on the circle. or equidistant to every point on the circle. Another thing you guys might remember is that there's going to be radius. A radius is equal to half of the diameter. You guys might also know the equation that x squared plus y squared is equal to r squared. This is the equation of a circle where the center is located at 0, 0, and we have r is our radius. You guys might even remember the equation of x minus h squared plus y minus k squared is equal to r squared. And that is also the equation of a circle, and that's where hk, it's the opposite of what you see for both parentheses, it's the opposite of what you see, is going to be your center. And that, once again, r is equal to your radius. But please know that there are many, many, many more things that we can talk about when it comes to circles. So I encourage you to write down as many things as you can think of that deals with circles. So I'm going to write and many more. So there are many more things that we can talk about when it comes to circles. But what we're going to do first is we're going to start graphing them. So like I said to you before, the equations of your circles need to be in the form of x squared plus y squared equals r squared, or x minus h squared plus y minus k squared equals r squared. And in example number 1, unfortunately, this equation is not in the format that we need it to be in. We need our x squared and y squareds to be on the same exact side. So what I'm going to do is I'm going to add y squared to both sides, and I'm going to add 4 to both sides. By doing that, the y squareds and the 4's will cancel out, and we will be left with x squared plus y squared is equal to 4. Now, based on this equation, we know that our radius, this is going to be our radius squared. So in order for us to find what our radius is, we're going to take the square root of 4, and that's going to equal 2. So our radius is going to equal 2. Our center is going to be located at 0, 0 because there's not any sort of parentheses. If you see parentheses, then that means that your vertex is going to be something else. So here's our radius and here's our center. When it comes to this 4 points thing that you'll need to identify, I always recommend north, south, east, west. These are the values that you're going to identify. So if I were to call this north, south, east, and west, those are going to be your ordered pairs that you're going to identify after you've plotted 0, 0 and counted 2 units north, 2 units south, 2 units to the east, and 2 units to the west. That's how you come up with 4 points to graph a circle. So I always count my radius up, down, left, and right, and I come up with ordered pairs. And then I'm just going to draw a smooth circle going through all of those points. Now, my north point, this point right here, is located at 0, 2. My south point is located at 0, negative 2. My east point is located at 2, 0. And my west point is located at negative 2, 0. Now, do you have to put NSEW? No, you do not. But I do expect to see correct ordered pairs identified. And that's how you graph a circle. So let's go ahead and look at example number 2. For example number 2, unfortunately, there is a number next door to x and y. And what we need to do is we need to get rid of those numbers in front. So I'm going to divide every single term by 4 because I want x and y to be alone. And on top of that, I'm going to rewrite my variables in alphabetical order. So now I have x squared plus y squared, because the 4's cancel out, is equal to 9. So 9 represents r squared. So if I wanted to write like r squared is equal to 9, so I'm going to take the square root of both sides, and I find that my radius is equal to 3. So my radius is 3. My center, because there are no parentheses, my center this time is going to be located at 0, 0. So in order for me to graph a circle, I'm going to plot 0, 0, and I'm going to count 3 units going north, south, east, and west. So I'm going to count going north, 1, 2, 3. Count going south, 1, 2, 3. Count going east, 1, 2, 3. And west, 1, 2, 3. To the best of my ability, I'm going to draw a smooth circle going through. Do your best to try to make this not look like a square. I know that that can sometimes happen. Try to make it as smooth of a curve as you possibly can, but I'm not going to be grading this based on, I mean, it has to look kind of like a circle. So now our 4 points, I'm going to identify my north, south, east, and west points. North, I have the ordered pair 3, 0. South, I have the ordered pair North is 0, 3. Sorry about that. We go 0 up 3, so 0, 3. Then we have 0, negative 3 south. East is 3, 0. And west is negative 3, 0. So those are my ordered pairs, my 4 points that are on my circle. So now, example number 3, what we have is we have a center that is no longer going to be 0, 0. We now have our h and k values. So remember that our general form is going to be x minus h squared plus y minus k squared is equal to r squared. And that's where h and k is your center, so it's going to be the opposite of what you see. So hk is your center, and in order to find those values, it's going to be the opposite of what you see. And that even goes for k, because k this time is located inside of the parentheses. So in this case, the opposite of a plus 5 is a negative 5. So negative 5 is going to be my x value of the center. And the opposite of a minus 1 is a positive 1. So my center is going to be located at negative 5, 1. My radius, since r squared is equal to 4, I'm going to take the square root of both sides. I'm going to end up with r equals 2. You do not need to show me this work. If you go straight to r equals 2, that's perfectly fine with me. I'm going to plot negative 5. So this is negative 1, 2, 3, 4, 5, up 1. So here's negative 5, 1. And now I'm going to count 2 units going north, south, east, and west. So here is 2 units north, 2 units south, 1, 2, 2 units east, and 2 units to the west. And I'm going to draw a smooth circle, a smooth like a curve going through all of those points, and here's my circle. And my ordered pairs, well, my first ordered pair is going to be located at negative 5. This time it's going to be 3. So all I did here was I took my y value and I added 2 to it. Then I have this point down here is negative 5, negative 1. So 1 minus 2 is negative 1. So that's like a shortcut. Going east, I have the ordered pair of negative 1, 2, 3, up 1. So that's going to be negative 3, 1. 2 minus 5 is negative 3. And then west. So I have negative 7, 1. So negative 5 minus 2 is negative 7, 1. So that's my north, south, east, and west. So you can do some adding and subtracting to try to figure out what those values are going to be, and that will certainly get you your ordered pairs as well if you don't really want to count. And knowing that pattern of adding and subtracting 2 to your x's and y's will help you whenever in later types of problems. So I'm just putting that out there. So now we're on to example number 4. And example number 4, I'm going to identify my center. It's going to be the opposite of what I see, and the opposite of minus 2 is positive 2. And the opposite of positive 3 is negative 3. So my center is located at 2, negative 3. My radius squared is equal to 9. So you take the square root of both sides and you end up with your radius is equal to 3. So I'm going to plot the point 2, negative 3. So I'm going to go over to 2, down negative 3. And here's my center. And from here I'm going to count north, south, east, and west. So here's going 3 units to the north, 3 units to the south, 3 units to the east, and 3 units to the west. And I'm going to draw a smooth curve going through all of those points. And here's my circle. And now I need to identify what these points are. So to the north, what I can do is I can take my y value and add 3. So -3 plus 3 is 0, and that certainly is located at 2, 0. Going to the south, we're going down, we're going to subtract 3. So -3 minus 3 is -6. This is located at 2, -6. To the east, we're going to the right, so I'm going to add 3 to 2, and so that's going to be 5, -3. And to the west, I'm going to take 2 and subtract 3, and 2 minus 3 is -1, -3. So those are your values. All right, now on the next page, what we want to do is I'm going to give you the center being the origin and a radius. And what we want to do is we want to write an equation of the circle with the given radius. So since our center is located at the origin, we're going to be working with the equation of x squared plus y squared is equal to r squared. So I'm going to write x squared plus y squared is equal to 4 squared. So 4 squared is 16. So my equation is x squared plus y squared equals 16. There's your equation. That is all you need to show. For letter B, I'm going to write x squared plus y squared is equal to the square root of 3 squared. A square eliminates a square root, so we're left with x squared plus y squared is equal to 3. And that is your equation of that circle. Then for letter C, I'm going to write x squared plus y squared is equal to parentheses 2 square roots of 6 squared. Please be careful with this one. For this problem, we have x squared plus y squared equals 2 squared. We're going to square each piece. 2 squared is 4. The square eliminates the square root, leaving us with 6. And 4 times 6, that is 24. So I have x squared plus y squared equals 24. You do not have to write this step. If you can go straight to 24, that is perfectly fine with me. So that is how you write the equation of a circle given the origin being your center and a given radius. So now we have 4 more examples, and then we are finished for today. So example number 6 says we're given a point, -4, 7, and it lies on a circle. The center is located at the origin. And what we want to do is we want to write the standard equation of a circle. So based on this information, our standard equation of the circle is x squared plus y squared equals r squared. And based on this information that we were given an x value, we were given a y value, and we were given our origin. And our origin being 0, 0, that's our h and k. But because we're adding 0, we're not going to be working with the HK formula. Instead, what we're going to do is we're going to find r squared, because that's the only piece of the equation that we're missing. So I'm going to substitute -4 in for x, and I'm going to write -4 squared plus 7 squared, and that's going to equal r squared. Our goal is just to find what r squared is. So I have 16 plus 49 is equal to r squared, and 16 plus 49 is 65. So 65 is equal to r squared. There is no need to take the square root of both sides because we are not interested in finding out what the radius is. We just need to know what the radius squared is. So now we are ready to write our equation, and that's going to be x squared plus y squared equals 65. That's our r squared, and we call it a day. Next, we have a point being -5, -11. This also lies on the circle. The center is also located at 0, 0, and we want to write our standard equation. So we do have an x value and we do have a y value, but what we're missing is our r squared. So out of x squared plus y squared equals r squared, we need to know what r squared is. So I'm going to let x equal -5, so I'm going to put -5 squared plus -11 squared equals r squared. -5 squared is 25. -11 squared is 121, and this equals r squared. 25 plus 121 is equal to 146, and 146 is equal to r squared. So I don't need to take the square root because I'm not interested to know what the radius is. I just want to know what the radius squared is. And so my equation is going to be x squared plus y squared equals 146. And there's my equation of the circle. So now what it says is we want to write an equation of a circle where the center is located at 2, -1, and our radius is located at 8. So I have an h value and a k value this time, so I'm going to be plugging those values into the formula of x minus h squared plus y minus k squared equals r squared. So I'm just going to substitute those values into my formula. And that is x minus h, so x minus 2 squared, plus y minus -1 squared, so y minus k squared, equals my radius squared, so that's 8 squared. Cleaning up this equation, we have x minus 2 squared plus negative makes a plus, that's y plus 1 squared equals 64. And there's your equation. We have one last example, and then we are finished for today. So it says, a business owner wants to buy a property within a 30-mile radius of the airport. She finds a property that is 10 miles to the west and 24 miles to the south of the airport. The question is the property within a 30-mile radius of the airport? Now, if you wanted to know if any point was located inside of a circle, you can figure that out by saying, is x squared plus y squared less than r squared? If it is, then that means that point is inside of the circle. But if x squared plus y squared is greater than r squared, then that means that the point that we're talking about is located outside of the circle. So in this problem, what we need to do is we need to write an equation of a circle. So we're going to pretend as if the airport is located at 0, 0. And if our radius is 30, going all the way around the circle, our radius is 30. We have a center at 0, 0, and a radius is at 30. We can write the equation of the circle by making this x squared plus y squared is equal to 30 squared. And 30 squared is 900. So now we need to figure out, is this ordered pair? We need to come up with what that ordered pair is. So if we're talking about 10 miles to the west, if we were to look at this as north, south, east, and west, 10 miles to the west and 24 miles to the south. So we're going to assume that that's about right there. We need to verify, is this ordered pair? I'm going to say that this ordered pair looks like it's about -10, -24, because we're going to the west and south. So it's based on my quadrants, that's what I'm going to say the ordered pair is. We want to know, did we approximate that correctly? Is it indeed going to be inside of the circle, or is it going to be outside? So what we're going to do is we're going to substitute these values into our equation. So I'm going to write -10 squared plus -24 squared. I'm going to see how that is related to 900. Maybe it's even on the circle. So that's going to be 100 plus 576. Is that equal to 900? Well, this is 676. And that is certainly not equal to 900. Instead, 676 is less than 900. And if it's less than your radius, then that means the point lies inside of the circle. So it's because it's located on the inside of the circle, we are going to say that the property is within a 30-mile radius of the airport. So that's our answer. The property is within a 30-mile radius of the airport. And that is the end of today's lesson. Hopefully this lesson was a little bit easier for you than the last lesson. If not, please make sure that you contact me, email me, let me know what's going on, and we'll go from there. I hope you have a wonderful day, and I will talk to you soon.